time at this kind of event, and I'm very happy to be here. I've been in this niche for like 6-7 months, so I'm Belgian, I worked in the Netherlands, I'm coming from formal verification, I'm now becoming a safety engineer, working at Altreonic for half a year. The emphasis here is on the adjective long, so I share some of the skepticism just presented with regard to safety. I'll give a general intro, then make some general remarks about safety engineering, and I'll present one specific hazard due to the time limit that was one of the first I wrote down when I conducted a hazard and risk analysis at Altreonic. And I'll elaborate on point 4, where we use formal models, mathematics, in order to increase our confidence, with emphasis on confidence. I'm never going to give a 100% guarantee about safety, but I'll increase my confidence about safety, and I'll give an example with regard to security. In fact, the denial of service attack. So at Altreonic, we provide solutions for trustworthy systems engineering. I'll give a screen snapshot of the Virtuoso Next designer at the end. Altreonic has decades of experience in real-time operating systems, so one of its operating systems is in space right now on an ESA mission, or I think the ESA mission has ended actually. And we also have Gödelworks, a portal. Every engineer at Altreonic, it's related to the V-shape model, every engineer at Altreonic has to follow a very rigorous approach, and we use the same portal to get things done. So we try to follow more the aviation industry in terms of being rigorous, rather than following, we definitely do not use Linux operating systems or anything like that, like I think Google Cars and other players do use, and that's for safety reasons that we don't want to do that. Now these two blue products give us an advantage in the niche of electric vehicles, because that's what it's about at Altreonic, and we call our electric vehicles Kurt vehicles to honor this logician, famous logician, Kurt Gödel. All of these Kurt vehicles run on the same Kurt platform, which I will say a bit more about later. Just a disclaimer at this point. As I said, I'm a computer scientist. I'm 6 months into this. If you're going to give me questions on electrical engineering, I might, just to be safe, ask you to contact my boss, Erik Verhulst. A couple of words about safety engineering. Well, if I claim that my electric vehicle is safe, one of the implications is that no harm will be done to anybody using the vehicle or anybody in the vicinity of the vehicle, and he or she should definitely not be killed in the process. There should also, broadly construed, safety also implies no loss of mission. Security, one implication is that a secure system will prevent maliciously injected faults which could otherwise cause harm. And another implication is that sensitive data that the vehicle carries around is protected, and so on. Now, one of the main points here for us is that security is a sub-case of safety, and I'm going to illustrate this. What I will not talk about is the last bullet, that many man-machine interface issues are also of great concern in this area. We have a roadmap at Altreonic. Step by step, we have already achieved step 1. We have a redundant architecture. So the light blue rectangle has 4 quadrants. Each quadrant represents a box, and each box contains a controller, suspension, motor, battery, so it's redundant. Maybe just to digress, if you are potential clients for Altreonic, we can go for an even lower price by getting rid of the redundancy. But by default, we have redundancy built in. Electric propulsion, steer-by-wire. We are working on number 2. I'm going to talk about number 3. I've worked on this for a couple of months by focusing on verified software with regard to remote steering. Now, why am I going to talk mainly about remote steering here? Well, I'm going to try to convey to you that this is already a very difficult problem in terms of safety and security. We would eventually, it's a prerequisite for step 5 where we want to go with Altreonic. That's to go for semi-autonomous driving. For example, we have potential customers in controlled environments. So as a designer, we know the environment. We don't want to replace the human completely out of the loop. We will have one human for 5 to 10 vehicles. That is already ambitious enough. By the way, I would also like to mention at this point, based on previous presentations, that a self-driving car, which we are rather skeptical about at Altreonic, will it ever happen? Yes or no? But when you take the human driver out of the loop, the software itself has been written by a human, so the human mistakes are still in there. I mean, software typically contains bugs. So that was already true before we were talking about self-driving cars. It's not a made-up excuse for safety engineering. Now I'm going to focus on remote steering. You can use this smartphone to maneuver our Kurt vehicle, or you can use your web browser, and then you will get images sent over. We're not talking once again about a car on any arbitrary road in the world. We're talking about a controlled environment, and if you use this remote control feature, you will have limited speed and acceleration options compared to the scenario where you're actually sitting on the Kurt vehicle. And it's also not the case that everybody in this room can just use their web browser to steer our vehicle. We have authentication built in for obvious reasons. Now the main hazard I'd like to talk about today with regards to remote control steering is this one. Outdated steering commands sent from the remote control device to the Kurt vehicle are not discarded. If that happens, we have a problem, for it could cause undesired and unpredictable system behavior. And coming back to the V model, for example, this hazard, which I wrote down a couple of months ago, resulted in a new and short, concise specification, safety specification, which we should now respect at Altreonic. The Kurt vehicle shall not execute outdated steering commands. Full stop. Note that no mention is made where these outdated commands come from, whether it's from some remote control device or perhaps from the person sitting on the vehicle steering in that manner. Now I'm going to elaborate on this specification and try to convey some of the technology we use, formal modeling, using MuCRL2, because I worked at Eindhoven University. What we have is a listener L process running on the remote control device. It receives every now and then user input from the remote control driver, which it has to get across a wireless channel to the Kurt K process, which runs on the vehicle. This process running on the vehicle frequently gets sensor values, which it has to send across the wireless channel to the listener or other listeners. So we have a concurrent system, and we have broadcasted messages going from the Kurt to the listener, and the protocol works as follows. Once a broadcast is received, then and only then can a listener send its steering request to the Kurt K process. That's a lot for 15 minutes, so just giving you the flavor of things. What I do then, putting on my mathematical hat, is I put the listener L process in parallel composition with the Kurt K process using this MuCRL2 algebra. Based on many discussions with engineers at Altreonic, I then finally write down in an algebraic form. You see there are pluses and multiplications. It's an algebra. I capture the behavior of the listener L process. No need to try to understand all of this. Let me just say that I'm also modeling the possibility that packets that are sent across even get lost. So this is a couple of lines. It's the power of the formalism. You can express quite a lot. And I do the same for the Kurt K process. And this is going to give you, using the tool, a lot of advantages, because I can press one of the buttons on the tool and obtain different scenarios. This is one scenario which is going to illustrate one notion of what an outdated steering request means. So here we have, so time is is increasing as we go down, and we have user input from the remote control driver, which the listener process is caching. In the meantime, the Kurt K process receives sensor values. It tries to broadcast that, but the packet gets lost, so it never arrives. And fortunately, we have this safety mechanism built in on the listener side, because what we don't want to happen is that several seconds later, a packet, broadcasted packet does arrive, and then this listener process would send this very outdated steering request. So we have this safety mechanism which we didn't have in the beginning, and this is something that shall not happen according to this model. This is not a claim about the final implementation. So that's why we use shall, not will. A second scenario that the tool can generate is that when this broadcast does immediately arrive here, and so the listener is allowed to immediately send its steering request, because it happens in this window, well, because of the latency on the delay channel, on the communication channel, the delay, it arrives after this window of reception. So we have, thanks to this timeout here, we have a mechanism built in to discard this packet, because this is a second example of an outdated steering request. And then a third thing that could go wrong, and it's a third mechanism we have built in so that it doesn't happen, is that assume that the broadcast immediately arrives. We have a successful transmission from a steering request, but an extreme amount of delay, so that it ends up in a second frame of reception. Well, it's only by adding timestamps to the packets and using the real-time clock on the Kurt process, I'm not going to go into the details, that we can discard this kind of outdated steering request as well. So now I have elaborated on this safety specification, and what this formal modeling does, it at least gives you conceptual clarity, giving you three notions of outdated steering commands, and that's what the tool does for you. But then now as a human, I mean as a safety engineer, I try to be a bit malicious myself and try to be skeptical. Have we covered all notions of outdated? Well, this is now made up by myself. This is now a malicious listener, where it receives a broadcast and it just keeps on sending as much as it can the same steering request. So this is a denial of service attack, and we need to have a precaution built in here. I'm not going to explain that, not only because of the 15 minutes, but because of company secrecy. But I can explain at this point how we solve the solution on the listener side. I'm going to define what an authentic listener is. So the remote control device we make at Altreonic will be a good one. It will not do this. We're not only giving the Kurt vehicle away, we're giving the remote control device away. And I'm going to have this new safety specification. An authentic listener cannot send two consecutive steering requests to the Kurt vehicle without having received an intermediate broadcast message. Now, using this MCRL2 tool, I can, based on that algebraic specification I presented a couple of minutes ago, press another button and get this finite state machine, which is a graphical representation of a mathematical model capturing the behavior of the listener / Kurt vehicle system. We have yellow states and black transitions, and I can then take that safety property which I just presented, formulate it in logic, which is expressed here, press a button, and then the tool will say the property holds. So I have modeled a good behaving listener with regard to this property. So that's it's some confidence I have that we're designing in the right way. Now that's just formal modeling. I was an engineer, as expressed in the introduction. I worked at IMEC, so I know how to write C code, and that's what we do mostly. We use the Virtuoso Next real-time operating system. What I do is, this is a screenshot of one of these programming tools we use at Altreonic with, here's the Kurt K task, here's the listener task, but now we add data structures like a FIFO and so on. I specify this graphically, I press the button, I get C code, I add more C code manually, and now I test and validate all of this on the Windows platform. And then we're very close to deployment, because then we test it on the real Kurt vehicle in many environments. Last slide. 3 ingredients for thought. Autonomous cars often requires connected cars. I've tried to explain today that even being less ambitious is already challenging enough, because wireless communication is intrinsically untrustworthy, as I've demonstrated with the remote control. So a lot of safety engineering is required to get this right. And I'm an advocate for a lot of testing, but also some formal modeling. I focused on software, not on hardware today. 2 more points just to mention in passing. Engine in a conventional car is a single point of failure, so we go at Altreonic for redundant architecture. Questions about this, please ask them to my boss, who has the system-wide picture. And then the dynamics. If a driver reading a newspaper, if that's a problem, because he doesn't have much time to react, then maybe we should first and foremost go for slightly less ambitious projects, vehicles in controlled environments with supervision, which is what we're trying to do. Thank you very much.